that corrects its aim mid-flight, a round that turns toward a moving engine, dodges ricochets, or waits to detonate until it hits the right part. That's not fantasy, that's the terrifying promise of smart bullets. Ammunition with onboard guidance, sensors, and microcontrol that make projectiles behave like tiny guided missiles. For a century, bullets were dumb: point, pull, fire. Precision came from the shooter and the rifle, not the round. Now miniaturization, microelectronics, and tiny actuators let engineers put sensing and steering inside a projectile. The result? Rounds that can adapt mid-flight to wind, target movement, or even last-second intelligence updates. The implications are massive, from surgical warfighting to new ethical questions about autonomy on the battlefield. What smart means. Smart doesn't mean explosive AI in a pellet. It breaks into layers, guidance, tiny sensors and control surfaces that tweak trajectory, sensing, optical, inertial, or radar sensors that locate and track targets, decisioning, pre-programmed logic that decides when to steer, detonate, or abort. Some designs aim for micro-adjustments to correct for wind or target acceleration. Others carry simple homing packages for high-value moving targets. The common thread is automated intent baked into the projectile. How close are we? This isn't purely speculative. Governments and defense contractors have long funded research into guided projectiles. Smart mortar rounds, guided artillery shells, and guided small caliber demonstrations exist. Advances in MEM sensors, miniaturized actuators, and low-power computing mean the size and weight penalty is shrinking. Breakthroughs in networking let a bullet receive a short, encrypted update from a drone or spotter mid-flight, refining its aim. Laboratory tests show guided behavior in controlled conditions. Transition to real-world, high-speed small arms is still a hard engineering problem, but the gap is narrowing. Use cases: surgical, tactical, and terrifying. Smart bullets promise precision like never before. Surgical strikes: disable a vehicle's engine rather than blast the whole car. Neutralize a specific weapon system while sparing nearby civilians. Long-range precision: allow snipers to hit moving targets at extended ranges with higher first-shot lethality. Counterswarm: tiny guided rounds to disable drone swarms by targeting control modules. But the same tech also opens darker avenues. Tiny guided micro-munitions could be used for assassinations with reduced forensic traces, or to attack soft targets with chilling efficiency. Technical hurdle: high level. There are brutal constraints: space, mass, power, and speed. A handheld rifle round experiences intense acceleration and spin. Any onboard electronics must survive that and still operate at thousands of feet per second. Communication windows are short. Control algorithms must be lightning fast. Guidance surfaces must be tiny and robust. Because of those constraints, most practical smart round concepts focus on larger calibers or submunitions deployed from artillery. Still, research into miniature guidance suites continues, and incremental gains compound quickly. Ethical, legal, and operational questions. Smart bullets force uncomfortable questions. Who programs the decision rules? If a round selects a target based on an algorithm, where does responsibility lie? International humanitarian law demands discrimination and proportionality, but automated projectiles blur lines. Do we allow rounds that autonomously decide to detonate when they detect a human chest? Many argue those decisions must remain human in the loop. Proliferation is another concern. As smart munitions drop in cost, non-state actors could gain access to precision attacks once reserved for nation-states. Export controls and treaty discussions will lag behind engineering cycles, as they always do. Countermeasures and defenses. If smart rounds appear on the battlefield, defenses will follow. Jamming or spoofing sensors, deploying decoys, armor-hardening critical components against precision strikes, and rapid detection systems that give warning of guided munitions will all evolve. The offense-defense spiral accelerates. Better bullets lead to smarter countermeasures, which lead to even smarter bullets. The result is an increasingly complex, expensive battleground. Near-term outlook. Expect incremental rollouts, guided features first in larger calibers and artillery, then specialized sniper rounds for high-value missions. Finally, if tech and policy permit, miniaturized packages for small arms. Militaries with deep budgets will push forward first, law enforcement and commercial uses will face stricter scrutiny. Ultimately, smart will be a spectrum, not a binary switch. Many future engagements will combine human judgment, remote guidance, and intelligent munitions, a hybrid that forces new doctrine, laws, and ethics into the open. We used to measure weapons by loudness and flash. The next era will be defined by silence and precision. Bullets that think, then act. That quiet calculus strips away much of the drama from war, but it raises the loudest questions about who gets to decide when a round fires and when it kills. When ammunition learns to choose, the truly dangerous debate begins. Who teaches the bullet how to judge a life?